For number 8, we have the ellipse defined by the equation in general form. So the first thing we have to go through and do is put this in standard form. Then we'll find the coordinates of the center, focus, vertices, and graph this. So to put this in standard form, the first thing I need to do is separate the x values from the y values. So I have 18x squared minus 144x. I'm going to group those together. The next one I have is going to be plus 12y squared minus 48y. And I'm going to go ahead and move the 120 to the other side. So all of this right now is going to equal to a negative 120. All right, so to do this, because the 18 and the 12y are not the same values and they're both positive, I know I have an ellipse. So when I'm looking at this, the first thing I need to do is out of this one is I need to factor out the 18. If I factor out the 18, I am left with x squared minus 8x. I'm going to leave myself a little gap here. And then over here, for the y's, I'm going to factor out the 12. And when I factor out the 12, I am left with y squared minus 4y. I'm going to leave myself a little bit of room here. And right now, that's still all equal to a negative 120. All right, so now comes a process where we have to go through and complete the square. So what value goes here? That's going to be negative 8 divided by 2, and I need to square that. Follow the signs with this. That's going to go ahead and be a plus 16. Now, the only thing is that I have to add that plus 16 to that other side. But when I add that plus 16, it's not just 16 I'm adding. It is actually 16 times the fact that I have 18 out front. If I were to distribute that back out, I'm not just adding 16, I'm adding 16 times 18. I do the same thing over here for the y value piece. So that's going to be my negative 4 divided by 2. I square that, and then I go through and add 4. But again, I'm not really just adding 4. I'm adding 4 times that, the fact that I multiply it times 12 on the other side. All right, now let's look what I have. What I really have now is 18 times x squared minus 8x plus 16 plus 12 here times y minus 4y plus 4. And all of this over here, if you add it all up, is going to equal 216. Now, what is this? This is a perfect square trinomial. So is, oops, I forgot my y squared. So is this. So I factor both of those. Now I'm left with 18. That becomes x minus 4 quantity squared plus 12 times y minus 2 quantity squared. That's all equal to 216. Because I have an ellipse, my ellipse, I know I have to have that 216 has to equal 1. So I divide every single term by 216. I go ahead and reduce this. 18 over 216 reduces to give me 12. 12 over 216 gives me 18. So what I am left with for my formula for my ellipse just is x minus 4 quantity squared over 12 plus y minus 2 quantity squared over 18. All of that is equal to 1. All right, so let's go ahead and we're going to talk about the values that I need and how to graph this. So what did I find here? This tells me that my center of the ellipse is at 4, 2. I get those values from changing the signs of the piece around x. So that's why my center is x is equal to 4. And then over here with y, that gives me a y value for my center at 2. Now the next thing that I know that I have there is that a is equal to the square root of 18, and I know it's a because 18 is the larger one. That is 3 square root of 2. This is going to be my major axis. The value underneath x is b, so b is equal to the square root of 12, and the square root of 12 will give me 2 square root of 3. That is my minor axis. All right, let me just move this out of the way for a little bit because we have to go ahead and find the exact value for the vertices. Now, what I'm looking at here, because I know that A is my major axis, what I have here, that is underneath my y value. So the change is on the y. So my center starts at 4, 2. So the x value for both of those will be the same. Now again, the change is on the y. So what happens here is this is going to become 2. One of them will be plus 3 square root of 2. And then the other value will be 2 minus 3 square root of 2. For the minor vertices, we have that's the square root of 12 or 2 square root of 3. And because those minor vertices are both underneath the x value is what changes, and then the y stays the same. So the pieces here, again, y is going to stay the same for both of these co-vertices. So that y value in both of those cases will be 2. But the x value is what will change, so that becomes 4 plus 2 square root of 3, and then 4 minus 2 square root of 3. The last thing I need to go through and find are the foci points. So let's go through and find out what c is. C squared is equal to a squared minus b squared, or c is equal to the square root of 6. So the foci move along the same axis as the major axis, so that means that x value is staying the same. And again, that's because the major axis is in y, and then I am just taking my y value of the center, so it's going to be 2 plus the square root of 6 for one of the foci, and the other one will be 2 minus the square root of 6. So now that I have all of the vertices, co-vertices, and foci, I'm going to go ahead and graph the ellipse. So the center of the ellipse is at 4, 2. To graph the vertices, I need to graph the value of 4, 2 plus 3 square root of 2. 2 plus 3 square root of 2 is approximately equal to 2.6. And down here for the other vertice, it's going to be 4, 2 minus 3 square root of 2. And that value is approximately equal to negative 2.2. So that gives me this is 4 and just a little bit more than 6 for my vertex here. And then this is 4 and negative 2.2. So about there. Now for the co-vertices in the other direction, what I have, that's going to be 4 minus 2 square root of 3, 2. And the other one would be 4 plus 2 square root of 3, 2. Those decimal values give me a 0.52, and over on the right hand side I have 7.52. So my values will be about here, and here. So now I have all that I need to graph that. I've already listed the foci. I don't actually have to draw those in. I can, but my graph of the ellipse will be about like this, and the two foci would be in the middle around there.